The word trigonometry comes from the Greek language meaning measurement of triangles. So today, let's talk about right triangle trigonometry. Let's recall something important we learned years ago about right triangles, the Pythagorean Theorem. So if you have a right triangle and the legs are lengths A and B and the hypotenuse is length C, recall that the Pythagorean Theorem says that A squared plus B squared equals C squared. So let's see an example. Suppose we have this right triangle here where we have the length of 12 centimeters as one leg and the length of 5 centimeters as the other leg. Let's find the length of the hypotenuse. Using the Pythagorean Theorem, since this is a right triangle, we know that A squared plus B squared equals C squared. A and B are lengths of the legs. So 12 squared plus 5 squared gives us C squared. We can solve for C squared, and we get that 169 is equal to C squared. So now to get C by itself, we have to take the square root. But remember, when you take a square root to solve, you have to take plus or minus. So we would get that C is plus or minus the square root of 169. But C is the hypotenuse. It's actually the length of a hypotenuse. And we remember that lengths are always positive, so C is actually just positive 13. Let's take a look at another example. Here's another triangle, right triangle, but now we're missing the length of one of the sides. We can still use the Pythagorean Theorem, A squared plus B squared equals C squared, to solve for that missing leg. So A squared plus 24 squared equals 25 squared. And we can solve for A squared, and we see that A squared is equal to 49. To get A by itself, we'll take the square root of both sides. But again, remember, whenever you take a square root to solve, you have to take plus or minus. Keep in mind, though, that A is the length of the side. So A is a length or a distance, and distances are always positive, so A is just going to be 7. So now let's look at this right triangle, and we'll consider that one of the angles we'll label as theta. So we know one of the angles is 90 degrees, so we'll label one of the other acute angles as theta. Then relative to theta, we have these three sides. The one across from the right angle, the longest length is always the hypotenuse. And then our two different legs, the leg that is opposite or across from theta is called the opposite leg, and the leg that helps make up theta with the hypotenuse is called the adjacent leg. So based on this right triangle, we can define our 6 trigonometric functions for this angle theta right here. So theta is an acute angle of the right triangle, and we can define the sine, the cosine, the tangent, and their reciprocal functions as follows. So the sine of this angle is actually the ratio between the length of the opposite leg and the length of the hypotenuse. The cosine of this angle is the ratio between the length of the adjacent side and the length of the hypotenuse. And the tangent of this angle is the ratio between the length of the opposite side and the length of the adjacent side. Once you have sine, you can easily get cosecant, it's just the reciprocal. Once you have cosine, you can easily get the secant, it's just the reciprocal. And once you have tangent, you can easily find the cotangent because it's just the reciprocal. So the cosecant will be the hypotenuse over the opposite, the secant will be the hypotenuse over the adjacent, and the cotangent will be the adjacent over the opposite. Now notice for these little abbreviations, OPP is the length of the opposite side of theta, ADJ is the length of the adjacent side to theta, and the HYP is the length of the hypotenuse, which is the side across from the right angle. We have a little mnemonic device that can help us remember sine, cosine, and tangent of theta, referred to as SO, CA, TOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for example, let's suppose we have this right triangle right here where we have two legs, 12 and 16. For this angle theta, now notice where theta is, we're going to find all 6 trig functions for that theta. Well, the first thing that we're going to need is we need the length of the hypotenuse. So we're going to have to use the Pythagorean Theorem like we did earlier to find C. So A squared plus B squared equals C squared. So 16 squared plus 12 squared equals C squared, and we can start solving for C. Now here, when we have 400 equals C squared, remember in order to take the square root of both sides, whenever you take the square root to solve, you have to take plus or minus. But C is a length, and lengths are always positive. So C is actually just positive 20. Now we have the triangle complete. We can find the sine, the cosine, and the tangent of this triangle. So here's our angle here. Remember, sine is opposite over hypotenuse. So the length 12 over the length 20, which reduces to 3 over 5. Once you have the sine, it's really easy to get the cosecant because it's just the reciprocal. Just switch the numerator and the denominator, and you get that the cosecant of that angle is 5 over 3. Next, we can find the cosine, which will be the length of the adjacent over the hypotenuse, 16 over 20, which reduces to 4 over 5. Once we have the cosine, it's really easy to find the secant by just taking the reciprocal 5 over 4. And now the tangent will be the length of the opposite over the length of the adjacent, 12 over 16, which reduces to 3 over 4. And now we can easily find the cotangent by taking the reciprocal 4 over 3. Let's take a look at another example. Let's visit this triangle right here. So notice now we're missing one of the legs. So we're going to find all 6 trig functions for this angle theta. First thing we're going to have to do is find this missing leg. So a squared plus b squared equals c squared using the Pythagorean theorem again. We get a squared plus 8 squared equals 12 squared. And we can start solving for a squared. So here we get a squared equals 80. And again, when you take a square root to solve, you have to take plus or minus. You get plus or minus the square root of 80, which reduces to 4 square root of 5. But since a is a length, then we only have to take the positive. So now we can relabel this triangle where we have this missing length right here, 4 root 5. So for theta, we can do the sine, which is opposite over hypotenuse, 8 over 12, which reduces to 2 over 3. Once you have the sine, it's pretty simple to get the cosecant, just take the reciprocal. Now we can find the cosine adjacent over hypotenuse. That 4 over 12 will reduce to 1 over 3, and that we get square root of 5 over 3. To find the secant, we'll just take the reciprocal of that, 3 over root 5. But if you recall, we don't leave square roots in the bottom, so we have to rationalize. So we multiply the top and the bottom by the square root of 5 to get that the secant of this angle is actually 3 root 5 over 5. And then the tangent, which will be opposite over adjacent, would be 8 over 4 root 5. 8 over 4 reduces to 2. Again, we have that square root in the denominator, so we're going to rationalize by multiplying the top and the bottom by the square root of 5 to get that the tangent of that angle is 2 root 5 over 5. Now, for the cotangent, we are going to take the reciprocal. But if we take the reciprocal of this finalized answer of the tangent, we would have to rationalize again. So actually take it back one step. Before we rationalize the tangent, and we had 2 over root 5, take the reciprocal of that to get your cotangent, square root of 5 over 2. So here's an application problem of right triangle trigonometry. So suppose a 10-meter long ladder leans against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? And how far from the wall is the base of the ladder? And we'll round our answers to 2 decimal places as needed. Whenever you're working with word problems, the best thing that you can do for yourself, if ever possible, is to draw a picture. So we'll assume that this is the building, this is the ground, and we always assume that the ground and the building make this nice right angle. And here's the ladder leaning up against it at a 60-degree angle, and that ladder is 10 meters long. So looking at this triangle again, we can't use the Pythagorean theorem because we don't have the length of either of the legs. So we want to determine h, the height of the ladder against the wall, and the distance d from the base of the ladder to the base of the building. So what information do we have here? Well, we know that this angle is 60 degrees, and we know that the hypotenuse is 10 meters. So how are 60 degrees and 10 meters, what kind of a relationship can we develop here? Well, using right triangle trigonometry, we know that the cosine of 60 degrees would be the adjacent over the hypotenuse. We also know that the sine of 60 degrees would be the opposite height over the hypotenuse 10. So let's look at the cosine. The cosine being the adjacent over hypotenuse, which would be d over 10. Well, if you look back at your unit circle, you know that the cosine of 60 degrees is 1/2. So using that information, knowing that the cosine is d over 10, and the cosine of 60 degrees is 1 over 2, we can set that 1 over 2 equal to d over 10, and we can solve for d, which means the distance from the base of this ladder to the building is 5 meters. So now we can revisit this triangle, filling in this missing blank right here. And we have that this base right here of this triangle is 5. Now you have 2 choices when it comes to, well, you have multiple choices, but I'll tell you about 2 choices you have for finding h. You can use that the sine of 60 degrees is h over 10, and that the sine of 60 degrees is root 3 over 2, and you can do exactly what we just did on the previous slide with the cosine and solve for h. Or we can use the Pythagorean identity now that we have this leg. So we know a squared plus b squared equals c squared. So 5 squared plus h squared equals 10 squared. And we can solve for h. And we get that h squared is 75. So we take plus or minus the square root of both sides. And when we simplify the square root of 75, it's 5 root 3. But again, this is a height, which is a distance or a length, and those are always positive. So it turns out that this height is exactly 5 square root of 3 meters, which will round to the second decimal place to be about 8.66 meters. Now I know this isn't in the notes, but I have a little bonus example to help you with your homework. So I'm going to help you set this up and you can solve from here. Suppose you know that the tangent of theta equals 2 over 5. That's all the information we need. We can find the other 5 trig functions for theta. So if we know that the tangent of theta is opposite over adjacent, which is 2 over 5, then we can draw a triangle, any right triangle, and label one of the angles to be theta. So if opposite over adjacent is 2 over 5, then we can label the opposite leg as 2 and the adjacent leg as 5. Then you can use the Pythagorean theorem that we've done several times before to solve for the length of the hypotenuse. And then you get that you have this length of 2, this length of 5, the hypotenuse is the square root of 29, and now you can use your right triangle trigonometry to find the sine and the cosine and the tangent and the reciprocals of all of that angle theta. That's it for now. See you next time.